Okay, today we're going to talk about a series. The last lesson was about sequences, just figuring out what the sequences look like and how to figure out the next terms in the sequence, and on and on and on and on. So here we have an arithmetic sequence, or an arithmetic series. It's just the sum of an arithmetic sequence. So here I have an example already on the board, and I see that I'm slightly covering myself there. So let me move myself out of the way. There we go. So evaluate the related series of each sequence. So here I have a sequence, and I want to evaluate what it would be. All I got to do is take each of those numbers that are there and add them. 42 plus 52 plus 62 plus 72 plus 82 plus 92 plus 102. I just add those, 7 numbers up, and I get something like 504. So that's my sum for that problem. I would just add those numbers up. That's all I got to do. That'd be really simple if that's all it was, wasn't it? Let's see how these things change a little. So, evaluate each arithmetic series described below here. So the first one, instead of just 7 numbers like I had in my example above, we've got 16 numbers. And they didn't even tell us what the rest of the numbers are. We'd have to figure them all out. Number 2, it just told me what the first one is, what the difference is, and how many numbers. I don't have any of the numbers. For 3, I've got the first number and the last number, and I know how many terms. And then, well, it's not even, yeah, I mean, seriously, what? This one problem right here is referred to as sigma notation. This sideways M thing, this E-shaped type thing, is actually a Greek symbol, sigma. And all sigma means is add up. Add up this formula, 9n minus 14, when n starts at 1 and it goes through 6. So I would put a 1 in there and figure out the number. I'd put a 2 in there, and I would stop when I got a 6 in there. And then I would just add those numbers in. That's all that means. So that big sigma right there, don't want to freak you out, it just says sum up. So we got to add things up. So we have these 4 completely different type of problems, and we could do, just like we did this one, find each term and then go ahead and add them up and get 504. We could do that. Small problem with that. That first problem down on the bottom, we have 16 terms. We don't have all 16 terms yet. We'd have to find all 16 terms. So let's see if there's another way we can do this. So bear with me. Here I have this 6-term series. I got 8 plus 24 plus 40 plus 56 plus 72 plus 88. Okay, so here's my series. I'm going to use this series to see if we can't figure out a way to create a formula that's going to make it work a ton easier for us. So the first thing I'm going to do is be upset that my board's not moving like I want it to. I'm going to reverse the order of those numbers and then just add both of those sets together. So when I do that, I get 8 plus 88 is 96. 24 plus 72 is 96. Every time I add these, because I have a reverse order, every number comes out to be exactly the same. Now, that's 2 of my sums of these 6 terms. So now, I could simplify this right-hand side. I have 6 96s. Gotta go that a little bit lower. There we go, 6 96s. So now I could say the sum, it would just be if I divided by the 2. There we go, sum divided by 2. Okay, so I got the sum divided by 2 of the 96. Well, how did we get the 96? To get the 96, we just added the 8 and the 88. Okay, so the 6th term, I've got to move this guy up a little bit. So we have that. So the 8 was our first term, the 88 was our last term. How we got the 96, we have the 6 over the 2 for the sum. So now, knowing that the n is 6, the A1 was 8, the A6 was 88, I'm going to replace the 6, the 8, and the 88 with their term values. So now I get S sub n equals n over 2 times a sub 1 plus a sub n. So if I know the first number and the last number in my series, and I know how many numbers are in my series, I can just use that formula. Now, I want you to recall from our sequence discussion that the nth term had a formula, the explicit formula. A sub n equals a sub 1 plus n minus 1 times d. So if I replace the a sub n in this pink formula with this formula for a sub n, I get this big ugly right here. N over 2 times the bracket of a sub 1 plus n minus 1 times d. Well, I can clean that up, and I get s sub n equals n over 2 times the bracket 2a sub 1 plus n minus 1 times the common difference. So here I have two different formulas that could help us. Now in the top formula, I need to know what the first term is, what the last term is, and how many terms. And for the bottom one, I need to know how many terms, what the first term is, and what the common difference is. Now, if we were looking in a book, it would have wrote it out like this and just told us, hey, here's your formulas. They're the exact same as one we just figured out. So let's go back to this. Okay, so for this first problem, I know the first term. I know a sub 1 is 8. I know n is 16. Now, if I knew what the last term was or what the common difference is, I can use one of those formulas. Well, 8 plus what gets me to set 15? Plus 7. 15 plus 22 is a plus 7. So my common difference is 7. So I'm going to use that second formula, which says the sum of the 16 terms is going to be 16 divided by 2 times 2 times the first term, 8, plus 16 minus 1 times my common difference of 7. Bracket. Bracket. Now all I got to do is follow the order of operations. 16 minus 1 is 15. 15 times 7 is 105. 2 times 8 is 16. 16 plus 105 is 121. 16 divided by 2 is 8. 8 times 121 is 968. And there comes some more thunder and rain. So I could have done it that way instead of, or I could have found all 16 numbers and add them up. I could use that formula. Okay, the second problem. I got a sub 1, I got d, I got n. I've got everything for that formula. I'm just going to go right into it. S sub 8 will equal 8 divided by 2 times, and I got 2, bracket, 2 times the negative 2 plus 8 minus 1 times 5. Close my bracket, follow the order of operations. So 8 minus 1 is 7. 7 times 5 is 35. 2 times negative 2 is a negative 4. Add 35, I get a 31. 8 divided by 2 is 4. 4 times 31 is 124. So I just used, on those two, I just used the formula that says S sub n is n over 2, bracket, 2 first terms, plus n minus 1 times the common difference. I just used that formula for those first two problems. Now, let's take a look at this third problem. I've got to move this other stuff down. Didn't give myself enough room. No. Look at these problems. We'll get to them. Okay. So this problem, I got a sub 1, I got an a sub n, and I got an n. That looks a lot like that other formula where it said S sub n was n over 2 times first term plus last term. All we got to do is plug right into that. So S sub 12 is 12 over 2 times 5 plus 27. So 6. 5 plus 27 is 32. So I get 192. That's my sum. So I could start at 5 and I could keep adding 12 or figure out what that common difference is and keep adding them up. All right. So this sigma notation problem. What might help us is to figure out at least what a couple terms are. Because we know n is going to equal 6 at the end. So what I would do is I would take 9 times 1 minus 14. That's going to give me my first term, which is a negative 5. I could put in a 2. 9 times 2 minus 14 would give me 18 minus 14. That's my second term, which would give me 4. Okay, so now I have the first two terms. I should be able to find the common difference between those. When I look at these two, the common difference is 9. Because I have to add 9 from -5 to get up to 4. So now I have the common difference. I know the first term is 5. I know, yeah, I have it. Or I can just continue this on and go straight to the 6. 9 times 6 minus 14 would be my a sub 6, which would be 54 minus 14, which would be 40. I don't know why I wrote 14. 40. So in this case, I have my last term, I have my first term, I have my common difference, and I know my number of terms. I can use any formulas, but when I get to these segment notations, if I can kind of cut out this middle step and just know what the first term is, the last term is, and how many terms I got, I speed up that process a ton. Because now I can just say, I got to take -5, add 40. That's going to be in my parentheses, so I'm going to use this formula. 6 over 2 is my s sub 6. So 3 times 35 gets me 105. So there's my sum there. Okay, so that's how we can find the sum. I have that formula right here. If I know the first and last term and I know how many terms, I can use this bracket form. If I know the first term and I know the common difference in the number of terms. So what happens if they want us to try to figure out the number of terms? So what happens when I get down here? I need to figure out the number of terms, which means I have to work those problems backwards. So let's see how we did each of these problems. This first problem, we had the numbers up to the terms. We used this formula. So let's clone that formula. Let's bring it down here to use it. Ooh, got it to the right spot. Okay, let's plug in what we know. We know the sum is 135. We don't know the n. Don't know that. We know the first term is 7. We don't know the n. Common difference. Well, what's it take to go from 7 to 9? It's a 2. So all we have to do is solve that equation for the n, and we have it figured out. So how do I solve that equation for the n? Well, let's go ahead and clean up what we do know. I'm first going to multiply by 2. Multiply by 2 there, multiply by 2 there. When I do that, here on the left, that divide by 2 gets canceled off. So 270 equals n times, okay, let's do stuff on the inside. 2 times 7 is 14. 2 times n is a 2n. 2 times a minus 2 is a -2. So I did the distributive property back here. You with me there? Okay. So let's see what I got. N times 2n. 14 minus 2 is a 12. So I've got 270 equals n times 2n plus 12, and I need to figure out what that's going to be to make that work. So I could guess and check and throw numbers in and see what I get. Mentally, I'm going, if I put a 10 in there, I get 10 times 32, too big. Maybe 8. 8 times 28. Probably not. Maybe 9. 9 times 30. Yes, n is 9. Because 9 times 2 times 9 plus 12 gets me 9 times 30, which is 270. So we got it. That's one way to do it. The other way to do it is to go back to Algebra 1. Let's go ahead and multiply the n through. So I get 270 equals 2n squared plus 12n. And now if I get it set equal to 0, So I'm going to minus the 270 to both sides. I get 0 equals 2n squared plus 12n minus 270. Now we can try to factor this using the whole method of factoring. We can use the quadratic formula. So I'm just going to throw that out to you, the quadratic formula. As a reminder, yes, I expect you to remember everything from Algebra 1. So given ax squared plus bx plus c equals 0, if then x equals the opposite of the b plus or minus the square root of b squared minus 4ac all over 2a. So in our case here, the a is a 2. Let's switch that. A is a 2. The b is a 12. And the c is a negative 270. So if I plug those numbers into that formula, I would say it's a negative 12 plus or minus square root of 12 squared minus 4 times 2 times the negative 270 all over 2 times 2. And now what's nice about that is I can just go ahead and use my calculator to figure things out. So x equals a negative 12 plus or minus over 4. Okay, so 12 squared minus 4 times 2 times the negative 270 is 2304. And the square root of 2304 is 48. So a negative 12 plus or minus 48 over 4. Well, a negative 12 minus 48 gets me a negative number. So that's out. So a negative 12 plus 48 over 4 would get me 36 divided by 4, which gets me 9. I got the same number as if I was doing it by guess and check. Okay, I know my time's running short here. So let's grab this other problem, bring it down here. Okay, so got a couple problems here. This problem here, I got my first term, I have my common difference. I would do it the same way we just did it. I would use the exact same formula. So I would say, 3925 equals n over 2 bracket 2 times 37 plus n minus 1 times the common difference of 10 bracket. I would again multiply both sides by 2. I would clean up the inside. I'd plug it through. I'd get an n squared thing going on through here, and yeah, I would use the quadratic formula. Okay, for this one, let's talk about how I would do this problem. I know the first term and the last term and the sum. That looks a lot like the other formula. N over 2 times first term and last term, and that's all we got. So if I plug in all the numbers I know, I got 414 equals n over 2. I still don't know what n is, but I know the first term is 10. I know the last term is 82. And now I just have to solve that out. So 414 has to be n over 2 times 92. Well, that's 92 over 1. 2 goes into 92 46 times. So I got 414 equals 46n. So I would just take 414 divided by 46. And I find out that again, I end up with 9 ways. Okay, answer is not always 9. This one here, if I work it out, n happens to be 25. So I just want to show you, it is not always 9. Okay, last problem. The way we did it when we were trying to find the sum is we went ahead and put the n in and we found the last term. So this one here, you're going to want to do using this method. We know the 460 equals n over 2 bracket. So if I put a 1 in for the k, I get 8 times 1 plus 2, and that gives me 8 plus 2 is 10. So my first term is 10 plus n minus 1 times my common difference. Okay, so now I better figure out my common difference. 8 times 2 plus 2 gives me 16, plus 2 is 18. So my common difference is 8. And now I would go ahead again and work through like I did the problem up above. I would get my 20, and I'd get my 8n minus 8. And I would, again, multiply by 2. So I get 960 equals n times this quantity. And I'll just keep working it. Okay, so that's a n times 8n plus 12. So I get 0 equals 8n squared plus 12n minus 960, because what I did was go ahead and distribute this to both of those, and I subtracted 960 at the same time I did the other part. So I get that equation, and now I could guess and check. I could factor it, or I could just plug it into the quadratic formula, and the quadratic formula says opposite of the, so a negative 12 plus or minus square root of 12 squared minus 4 times 8 times negative 960, all divided by 2 times 8, and I would just work that through all the way to the end. And if I work that through all the way to the end, 12 squared minus 4 times 8 times negative 960, I get 30,864 inside my square root. I've got 16 on the bottom. Okay, so negative 12 plus or minus 16, the square root of 3,000 whatever is a strange number. I got a mistake. That should have been a nice whole number. So I have a mistake. So what do? I got to go back and check my mistakes. What did I do wrong? My first term is 10 because 8 times 1 is 8 plus 2 is 10. So that is 10. My second term was 16 plus 2 is 18. That is a common difference. D would be 8, so that's right. So 8n minus 8, that's good. Oh, it's right here. 460 times 2 is 920. So this is a 920, so I should subtract 920 minus 920. So that's a 20. I'm going to go back into my formula and replace the, so 12 squared minus 4 times 8 times a negative 920 gets me 29,584. 29,584. Square root that value, and I get 172. There we go. Negative 12 minus 172 is a negative number. Ignore it. So negative 12 plus 172 divided by 16, which will give me 160 over 16, which will give me 10 terms in that sequence. Okay, so in this case, what we need to remember are these two formulas listed right here in our handy dandy little notebook. Oh, I'm sorry. Couldn't resist. Get a nice circle there. Maybe I can get it to pop up. There we go. So we've got the formula if I know the first term, the number of terms and common difference, or I have the formula if I know the first and last term and then that. So we have to have those handy dandy little formulas. And then the other thing that can help you on some of these problems is this magical right here, this quadratic formula. Good thing to have done. You're off. Okay, so your assignment, again, is online. It's in Google Classroom. It's the Sequence and Series Lesson 2 assignment. You're dealing with arithmetic series.